This video will look at solving radical equations, specifically equations containing square roots. We'll start with a simpler equation. To solve a radical equation, the first thing we check for is that the radical is by itself. This is already the case here. Next, to undo the square root, we will square both sides of the equation. Squaring the square root of 2x plus 6 leaves us simply with 2x plus 6. 8 squared is 64. This gives us a simple linear equation that we need to solve. We subtract 6 from both sides, giving us 2x equals 58, and then divide both sides by 2, and the solution appears to be x equals 29. However, with radical equations, we must check for what we call extraneous solutions. Extraneous solutions can occur when doing an operation like squaring both sides of an equation. An extraneous solution means that the answer, when plugged in, doesn't give a true statement, even though you didn't do anything wrong while solving the equation. So to be sure that 29 is the solution, we're going to check this into the original equation, the square root of 2x plus 6 equals 8. When we plug in 29, 2 times 29 is 58. 58 plus 6 is 64. And the square root of 64 is 8, which means that 29 is in fact the solution to this equation. Let's look at another example. X plus 2 square root of x minus 1 equals 9. A little bit more complicated. Again, the first thing we want to do is make sure the radical is by itself. In this case, we're going to need to subtract x from both sides, leaving us with 2 square root of x minus 1 equals 9 minus x. Now, technically, to get the radical by itself, we would want to divide 2 on both sides. However, in this case, that actually wouldn't be beneficial, as it would give us a more complicated expression. Since we can effectively square both sides and still get rid of the square root while leaving the 2 there, we'll just leave it on the side with the square root and square both sides, giving us easier expressions. On the left side, when we square 2 times square root of x minus 1, 2 squared is 4. Square root of x minus 1 squared is x minus 1, and we need to make sure that this is in parentheses. On the right side, we have 9 minus x squared, which we're going to need to multiply out as 9 minus x times 9 minus x. On the left side, we can distribute 4, giving us 4x minus 4. On the right side, we distribute 9 times 9 is 81. 9 times negative x is minus 9x. Negative x times 9 is minus 9x. And negative x times negative x is plus x squared. We can combine the two middle terms, giving us 81 minus 18x plus x squared. We can see here that we have a quadratic equation that we need to solve. In solving a quadratic equation, we generally try to keep the x squared positive. So let's move everything from the left side over to the right side of the equation. We'll subtract 4x from both sides, and I'm going to line it up with the other x term, and add 4. So on the left side, we have 0. On the right side, we have a quadratic equation. We're going to want the x squared first. So I'm going to put the x squared as positive x squared first. The middle term we'd like to be the x term, which is minus 22x. And then the final term we want to be the constant, so 81 plus 4 is 85. This is a factorable expression, so we can factor this as x minus 5 times x minus 17. We solve this by setting both expressions equal to 0 and solving. So we get two possible solutions, x equals 5 and x equals 17. Again, we must check for extraneous solutions. It's possible that these are both solutions to the equation, it's possible that one of them is extraneous. So we're going to have to plug both of these into the original equation, x plus 2 square root of x minus 1 equals 9. When we plug in 5, we have 5 plus 2 times square root of 5 minus 1 equals 9. And then 5 plus 2 times the square root of 4. And we can see here, 2 times the square root of 4 is 2 times 2, which is 4. And this works out. So 5 is definitely a solution to the equation. Now we have to check 17. When we plug in 17, we get 17 plus 2 times square root of 17 minus 1 equals 9. So we have 17 plus 2 times the square root of 16 equals 9. Here we have 17 plus the square root of 16 is 4. 2 times 4 is 8. And we can see here we get an untrue statement. This doesn't mean we did anything wrong. This is a common occurrence in a radical equation. Since this worked out to be an untrue statement when we plug this in, we call 17 extraneous, and we do not list it as a solution. So the only solution to this equation is x equals 5. Finally, let's look at one more equation that has two radical expressions in it, two square root expressions. In this case, we're going to use our method of isolating the radical on one side, but we're going to have to do this twice. So to start, I'm going to add one of the radicals to the other side of the equation. In this step, I'm just isolating one of the radicals. So I have square root of x plus 1 equals 1 plus the square root of 2x minus 5. Now, I'll square both sides. This will get rid of the radical on the left side and make this x plus 1. On the right side, I'm going to need to distribute this. So I have x plus 1 equals 1 times 1 is 1. 1 times square root of 2x minus 5 is square root of 2x minus 5. Square root of 2x minus 5 times 1 is square root of 2x minus 5. And here, square root of 2x minus 5 times square root of 2x minus 5 gives me just 2x minus 5. Now on the right side, I can combine some of the like terms. 1 and negative 5 can combine to be minus 4. Square root of 2x minus 5 plus square root of 2x minus 5 is plus 2 square root of 2x minus 5. And we still have plus 2x. And now we still have a radical in the equation, but we only have one. We can now isolate the final radical. So I'll add 4 to both sides, and at the same time I'll subtract 2x. So I have negative x plus 5 equals 2 square root of 2x minus 5. This is a similar situation to before. If you can divide 2 on both sides of the equation and it goes in evenly, then definitely divide both sides of the equation by 2. If it's going to leave you with a fraction on the other side, we can leave it with the radical. So we're going to square both sides to get rid of that last radical in the equation. So again, on the left side, I have to multiply this whole thing out. On the right side, 2 squared is 4. The square root of 2x minus 5 is 2x minus 5, but it needs to be in parentheses. On the left side, I can distribute. Negative x times negative x is x squared. Negative x times 5 is minus 5x. 5 times negative x is minus 5x. And 5 times 5 is 25. On the right side, I can distribute 4. And on the left side, I can go ahead and combine negative 5x and negative 5x to be negative 10x. And now, similar to the previous equation, I have a quadratic equation. So I need to get this equal to 0. while keeping the x squared positive to make it easier to solve. So I will subtract 8x from both sides and add 20, giving me x squared minus 18x plus 45 equals 0. This is again factorable. I can factor this to be x minus 15 and x minus 3. I will set both equal to 0 and solve by adding 15 to both sides and adding 3 to both sides. So again, I have two possible solutions, x equals 15 and x equals 3. They may both be solutions, or one may not be. We must check this into the original equation. The original equation is square root of x plus 1 minus the square root of 2x minus 5 equals 1. When I plug in 15, I have square root of 15 plus 1 minus 2 times 15 minus 5 equals 1. So I have square root of 16, and over here I have square root of 2 times 15 is 30, 30 minus 5 is 25, square root of 16 is 4, and square root of 25 is 5. And we can see here we get an untrue equation, which means that 15 is extraneous, and we are not going to include it in the solution. Next, we'll check 3. When I plug in 3, I have square root of 3 plus 1 minus square root of 2 times 3 minus 5 equals 1. So I have square root of 4 minus square root of 2 times 3 is 6. 6 minus 5 is 1. And now I have square root of 4, which is 2. Square root of 1 is 1. And I can see here that I get a true statement when I plug in 3, which means that x equals 3 is the only solution to this equation. Remember, you must check both solutions. Both can be solutions or one may not be.